Welcome to the June 2023 Edexcel GCSE. This is the 1MA1 series, paper 2H, the second one, the first of the calculators. Question 1A, if you can plug numbers into your calculator in the correct order, you should get 1.76527923. For part B, 0.625, if you recognise that that's 5/8, you can flip it to get 8/5 or 1.6 or 1 3/5. For splitting up 60, 60 is the same as 10 times 6, 10 is the same as 2 times 5, and 6 is the same as 3 times 2. Writing those as a product of its prime factors, 2 squared times 3 times 5. Part 3. The answer is no, I'm afraid. The actual ratio is 16 to 32. 1 to 2 is 16 to 32, not 24. Question number 4. The greatest possible value of n that's less than 5 is 4. When n's an integer. For part B, the -4, I'm going to colour that one in because it's less than or equal to. So between -4 and 1 with the -4 coloured in. For the inequality, I'm going to add 4 to both sides, times both sides by 5, and divide both sides by 2 to get g is strictly less than 25. Question 5, we know that the area of the triangle is 10 centimetres greater than the area of the rectangle. It allows us to construct an equation. So the area of the triangle, half times base times height, half times 8 times 6x is equal to the area of the rectangle. That's 5 lots of 4x minus 1. Add the 10 because of the 10 centimetres greater. Simplifying, a half times 8 times 6x is 24x. Expand out the right-hand side, 20x minus 5. Bring the x's onto the left, non-x's onto the right. Divide both sides by 4. We get x is 5/4, or 1 1/4, or 1.25. For question 6, first thing I'm going to do is find 57% of 800 by timesing by 0.57. That comes out as 456. Then we want to divide 456 in the ratio 12 to 7. So I'll add my 12 and my 7 to get 19 parts. 456 divided by the 19 parts means that there are 24 per part. Times that 24 by the 7 parts for the glass. And we get 168 kilograms. Question number 7, the lower bound is 12.65 and the upper bound is 12.75. Question number 8, we've got the compound interest. So for Tasmin, she's got her 150,000. We can times it by 1.04. And I'm going to square that because it happens over 2 years, giving her the value of her house would be 162,240. Then for Rachel, take her 160 grand house, multiply it by 1.015 squared, again because it's over 2 years. And that comes out as 164,836. So we'll compare those two numbers and decide that 164,836 is larger than 162,240. And therefore we can conclude that Rachel's house has the greater value. Okay, question number 9, so cumulative frequency. We always plot these at the end point, the part on the right. So the first one will be plotted at 30, 20. because it's 20 to 30 is at 20, and then at 40, 48, 50, 64, 60, 75, and lastly 70, 80. And then we have a go at drawing a line through all of those. And there's my mediocre effort. To work out the median, well, we're going to measure it at 40 bits of data because there's 80 in total, and that reads off as 37. Anything between 36 and 38 is acceptable for the median. Question number 10. The probability of it landing on a 6, according to the experiment, is 15 out of the 60. 15/60ths simplifies to a quarter. And so for it to land on a 6 2 times in a row, we need it to land on a 6 and on a 6 again. So times a quarter by a quarter, or square it if you prefer, and that's 1/16. For this to be true, well, n must be greater than 60. For it to be more valid, we need to have had more attempts. Question 11, simultaneous equations. I'm going to take the first equation and multiply it by 3, and the second equation and multiply it by 2. First equation becomes 6x plus 18y equals 15. The second one becomes 6x subtract 8y equals negative 24. I'm going to subtract the second equation from the first equation. Be careful when you're subtracting a negative 18y, subtract negative 8y is 26y. 15 subtract negative 24 is 39. Divide both sides by 26y equals 1.5. Substitute it back into any of the equations previously, and you can solve the equation to find that x is negative 2 if you do it correctly. X is negative 2, y is 1.5. Question number 12. A couple of ways of doing this one. I've decided to go with finding the radius approach. So there's a little right-angled triangle. The height is 5, the base is 4. We can do Pythagoras to find the radius of the circle. 4 squared plus 5 squared is going to be equal to the radius squared. So that's 16 plus 25, which is 41. So the radius is going to be the square root of 41. To find the circumference of a circle, we do 2 pi r, 2 times pi times the radius. So 2 times pi times the square root of 41, which comes out as 40.2 centimeters. Question 12. Question 13. So this is the non-right-angled trig. We've got a sine rule going on here. So sine of 70 over 18, that's the opposite. So it's going to be sine of the angle at C over 15. I know we want the angle at A, but once we have 2 out of 3 angles in the triangle, we can quickly work out the third. So C will be inverse sine of times both sides by 15 to bring it up and inverse sine it. Inverse sine of 15 sine 70 over 18, and that comes out as 51.5 degrees. Now we've got 2 out of the 3 angles. We can subtract them from 180 to find the third, which is the one the question wants, angle BAC, the angle at A. So 180 subtract 70 subtract 51.5 is 58.5 degrees. Question 14, simplifying an algebraic fraction. We're always going to want to factorize and cancel common factors. Numerator will factorize to x minus 3x plus 2, and the denominator factorizes to 2x plus 1, x minus 3. If you're feeling sneaky, you know that there's going to be some cancelling here. So factorizing the denominator, you know one of them is going to be either x minus 3 or x plus 2. You can use that to help you if you want. Anyway, cancelling the x minus 3's leaves us with x plus 2 over 2x plus 1. Don't be tempted to simplify further. It won't work. Question 15, our quadratic sequence, let's call that S, is 3, 9, 17, 27. And the first difference between each of those is 6, 8, 10 is not the same, so I'll calculate the second difference. Those are 2 and 2. So I'll halve that second difference to make 1, and I'll do that many lots of n squared, so 1 lot of n squared, or just n squared if you prefer, 14916, and I'm going to subtract 14916 from our sequence S, leaving us with 2, 5, 8, 11. That is a linear sequence. It's one less than the 3 times table, so we'll call it 3n minus 1. So S subtract n squared is 3n minus 1, add n squared to both sides. Our original sequence was n squared plus 3n minus 1. Question 16, we know 28 students were in the 30 to 40 hours. So if we divide that 28 by the class width 10, we'll get its frequency density. So the frequency density of that particular bar is 2.8. From that, you can clearly see that the frequency density scale is going at 1, 2, 3, 4. You see 2.8 high for the 30 to 41. Then for the 24 students between 40 and 60, we can divide 24 by the base, which will be 20. So it's got a frequency density of 1.2. Draw our line going across at height 1.2 between 40 and 60. We can work out the other frequencies now by multiplying their heights by their widths. And then to find the total number of students, we can add them all together. And they sum to 120. Okay, question 17. For part A, we're setting up an iterative formula, fairly straightforward. I'm just going to bring the x squared plus 5 onto the right-hand side and fourth root both sides. So x will be equal to the fourth root of x squared plus 5. Then for part B, setting x0 is 1.5 and just 1.5 squared plus 5 and fourth root it, you get 1.64. Take 1.64, do that again, and you'll get 1.67. And if you keep doing that, actually you will stay on 1.67, which is one of the solutions. So 1.67. All right. The ratios one, this one's a little bit abstract, I thought. But anyway, I'm going to start with 2a to 5c equals 6 to 25. Therefore, a to c is going to be 3 to 5. And b to c, where it was 4b to 7c is 20 to 21, b to c is going to be 5 to 3. Then want to line up the c's, so I'm going to make both of the c's 15. So I'll take the first one and multiply both parts by 3, take the second one and multiply both parts by 5. We get a to c is 9 to 15 and b to c is 25 to 15. That allows me to set up a ratio with the three of them. A to b to c is 9 to 25 to 15. So a plus b is going to be 9 plus 25. B plus c is going to be 25 plus 15 parts. So that's 34 to 40. And 34 to 40 simplifies to 17 to 20, which is what the question wanted. Question number 19. So this is SOHCAHTOA with bounds. I'm going to list the upper and lower bound of AB and the upper and lower bound of AC. So the upper bound of AB is 9.35, the lower bound of AB is 9.25, the upper bound of AC is 12.65, and the lower bound of AC is 12.55. Now we want to minimize this angle, the lower bound of the angle. So we know sine of the angle is going to be AB over AC. Now you can test these out if you can't quite see why, but I'm going to choose the lower bound of AB and the upper bound of of AC, and that's going to give me the lowest possible outcome when I do inverse sine of it. Again, you can test these out with sine. It's to do with the shape of the sine curve. if you want to dig into it a bit more. Anyway, so inverse sine of 9.25 over 12.65 comes out as 46.98921, and three significant figures, that's 47.0 degrees. For the vectors question, we want the vector m to t, so my path, I'm going to go from m to o and then from o to t. M to O, we know from the question, is going to be 2/5 of R to O, because O to M to R is 2 to 3. So that M to O is 2/5 of that whole side length. And O to T is just little a. Now R to O, we could imagine going from R to T and then T to O, so it's going to be B subtract A. So 2/5 of R to O is going to be 2/5 of B subtract A. Add the little a, and then expand out the 2/5 of b minus a to get 2/5 b minus 2/5 a plus little a. Group together the a's, we're going to get 3/5 of little a plus 2/5 of little b. Question 21, that's a translation along the vector 0, -4. So it's going down 4 places. So just move it down by 4 and draw it there. And then we've got a reflection in the y-axis, so it's just going to reflect on the other side, and you can draw it there. Question 22. Okay, we don't know the number of red pens or blue pens. However, we know there's 4 times as many blue pens. So if I say that there are x red pens, then there are going to be 4x blue pens, and there's going to be 5x pens in total. So the probability of picking a red pen at random is going to be x divided by 5x, or if you prefer just a fifth, it doesn't matter what x is. And the probability of picking a blue pen is going to be 4x over 5x, which is 4/5. Now, to work out the probability of having at least one of each colour, I'm going to subtract the probabilities of it being just one colour for reds and for blues, and then subtract that from 1. Now the probability of them all being red is going to be 1/5 to the power of n. The probability of them all being blue is going to be 4/5 to the power of n. So I'm going to subtract those two from 1, and that is my expression to answer the question. Okay, for the similar shapes, it gives us the scale factor a to b to b to c to c to d. We need to jump to the scale factor of areas, we need to consider similar shapes. Now trapeziums are not similar to triangles, so I'm going to rewrite the ratio of a to b to a to c to a to d. We're looking at the side lengths of similar triangles, which are going to be 1 to 3 to 6. I'm just adding together the parts there for each one. Then to jump to the scale factor of areas of the triangles, that's ABG, ACF and ADE, we can square those 3 lengths, so it's 1 to 9 to 36. And that's a scale factor of areas of the triangles. And then to get the scale factor of areas of the separate shapes, ABG, BCFG and CDEF, we can subtract the number of parts to just leave us with the bits that we want, essentially. So ABG is still 1. BCFG is going to be ACF subtract ABG, so 9 take away 1. And then for the CDEF, we're going to do the 36 take away the 9 parts of the triangle above it. And then that's going to turn into 1 to 8 to 27, which is what the question wanted. Question number 24, this is the one that made the headlines in the news about impossible GCSE maths questions. Well, it's not impossible, and here's how to do it. So I'm going to split the shaded area up into a square with 4 triangles around the outside. We know that those side lengths are little a. Each of the triangles is a right angle triangle. The internal angle of an octagon is 135 degrees. 2 lots of that subtracted from 360 will be 90. So we know we have little right angle triangles there with height a, width a, and that length, the hypotenuse, is going to be the square root of 2 lots of a squared, or if you prefer root 2a. So the side length of the square is going to be the 2a's on either side plus root 2 lots of a. So the area of the whole square that we've carved out is going to be the a's added together plus a root 2a all squared. And then to get the whole shaded region, we need to add 4 of these triangles, which is going to be half times base times height, half times a times a. So there's a complete expression for the shaded area. I'm going to simplify the a plus root 2a plus a by joining the a's together. So we get 2a plus root 2 lots of a all squared. 4 times a half times a is 2a squared. Then to expand out the brackets, 2a times 2a is 4a squared. Then you're going to get 2a times root 2a is 2 root 2a, and there's going to be 2 lots of those. So it's going to be 4 lots of root 2a squared, plus the 2a squared from root 2a times root 2a, plus the 2a squared at the very end. Let's join together the integer multiples of a squared to get 8a squared, plus the 4 root 2 lots of a squared, and we'll factorize out of 4 from the front, and I'll put the a squared at the back because it's a sort of a coefficient of a squared, and we get 4 lots of 2 plus root 2 a squared, which is what the question wanted us to. In this case, our value of p will be 4. Well done if you managed to work that one out. It was a great question. Bye.